Guaranteed. Guaranteed. What can be commented on the nature of this cylinder in the given context? Go. Repeat the question. Guaranteed. What can be said about the nature of the cylinder in this context? Go. Sir, I didn't understand the question. Well, if you would have understood, then you would have told me the answer. Question is perfectly valid. The cylinder must be dash. Go. The cylinder must be dash. Go. Come on. The cylinder must be non-conducting. How do you know that? Because if it was conducting, my dear, the entire charge would have come on the surface. Under electrostatic conditions, if you want the charge to be distributed in volume of a body, that volume of the body cannot be conducting in nature. Because for a solid conductor, if you give any charge, no matter where you give it, under static condition, that charge will automatically go where? To the surface. To do what? To make the field zero in the meat. Good now? Good. What's the question? Find the electric field at a point P. Okay. At a point P inside the cylindrical volume. At a point P inside. So can I say your point P is X, whatever it is. X is less than R. Do you agree with me? Yeah. Fair enough. Isn't it? If you have to be inside the cylinder, your X distance from the axis of the cylinder should be less than the radius. Now, otherwise, you will go outside. Correct, sir. Got it, sir. Okay. Let's mark the point. Here we go. Consider a Gaussian surface. Sir, what about the length of the Gaussian surface? Should it be infinite? Now you won't ask me that question. Got it, sir. Got it. Anna? Because Gauss law's advantage is that you can take any size of Gaussian surface. When you apply on it, the field will be due to everyone, inside and outside. So what is the prerequisite for Gauss law to become useful? Good. Symmetry. Very good. So applying Gauss law. Integral E dot ds is equal to Q enclosed by epsilon naught. Integral E dot ds is equal to Q enclosed by epsilon naught. Consider a cylinder coaxial with the given cylinder of radius x, length L. What is L? Don't know, don't care. Don't know, don't care. Okay. Applying Gauss law on that cylinder. So first term would be the entire cylinder. Instead of cylinder now, can I say GS? What's GS? GS is short for Gaussian surface. Let's do that, sir. In our case here, is there any flux through the top? No. Is there any flux through the bottom? No. The flux is only through the curved surface. So very simply, my expression becomes EDS, only the curved, Q enclosed by epsilon naught. Perfect, sir. Capish? Capish, sir. E can be out. Why? Because magnitude-wise at every single point E will be same. Aye, sir. E is out. Without further ado, can you please tell me what is the value of the curved surface area of the given cylinder, Gaussian surface cylinder? 2 pi RL, sir. Who plays the radius? Sir, X. 2 pi XL. Agreed or not? Aye, sir. Good. Can you please tell me how much is the enclosed charge? It's not a line. It's not a line. It's a solid cylinder. So rho will be the volume charge density. What will you multiply rho with? The volume of the chosen cylinder. What's the formula for volume of a cylinder? Sir, pi r square h. Who plays radius? X. And who plays h here? Sir, L. And yet again the sweet sight of L getting cancelled. Nice. In fact, sir, you know what? In fact, even pi is getting cancelled and x is also getting cancelled. You know what I'm getting, sir? E of x less than r. Sir, my answer is coming out to be rho x upon 2 epsilon naught. In fact, can I make it rho x vector? Because wherever the x is, the field will be there. My answer is x less than r. Click. What do you know? Hey, this is for the points inside, not outside.